The universe is vast, with unimaginable distances. We yearn to explore its distant corners, but time and space seem insurmountable. What if we could bend the very fabric of the cosmos? Imagine traveling through time like we travel through space. Picture a space-time machine capable of such feats. This is the stuff of dreams, of science fiction.
Space-time is not a static stage. It's a dynamic entity that can be warped, twisted, and even torn. This realization dawned upon us with Einstein's theory of relativity. This theory revolutionized our understanding of gravity and unveiled the profound connection between space and time. It opened up a Pandora's box of possibilities, including the tantalizing prospect of time travel.
The journey to understand space-time is a journey into the heart of existence itself.
Before Einstein, we saw space and time as separate entities. Time flowed at a constant rate, unaffected by the events unfolding around it. Space was a static stage, a backdrop against which the drama of the cosmos played out. But Einstein shattered these notions with his groundbreaking theory of relativity. Einstein revealed that space and time are not absolute. They are relative, dependent on the observer's frame of reference. Imagine two observers, one stationary and the other moving at a high speed. Time would actually pass slower for the moving observer relative to the stationary one. This phenomenon, known as time dilation, has been experimentally verified. Relativity also describes how massive objects warp the fabric of space-time. Imagine a bowling ball on a stretched rubber sheet creating a dip. Similarly, massive objects like stars and planets create gravitational wells in space-time.
If space-time is like a fabric, can it be folded? Can we create shortcuts through this cosmic tapestry, connecting distant regions of the universe? This is the tantalizing possibility offered by the concept of wormholes. Imagine a sheet of paper with 2 points marked on it. But what if we fold the paper, bringing the 2 points close together? This fold represents a wormhole, a theoretical tunnel through space-time. By traversing this shortcut, we could bypass vast distances. Wormholes also hold the potential for time travel.
The concept of manipulating space-time to achieve time travel or faster-than-light travel is tantalizing. But the technological hurdles we face in achieving such feats are monumental. Bending space-time to the degree required for wormholes or other forms of space-time manipulation would require unimaginable amounts of energy. We're talking about energy scales far beyond anything we can currently generate. Even harnessing the power of entire stars might not be enough. Furthermore, we would need a way to contain and control this energy, directing it with pinpoint precision. Then there's the issue of exotic matter, a hypothetical form of matter with negative mass and energy density. However, we've never observed exotic matter, and its very existence is debatable. The forces involved in bending space-time would be extreme, and any slight miscalculation could have catastrophic consequences.
The prospect of time travel raises profound philosophical and ethical questions. What are the implications of altering the past or glimpsing the future? Can we change the course of history without unraveling the very fabric of reality? One of the most perplexing issues is the grandfather paradox. Imagine traveling back in time and accidentally causing the death of your grandfather before your parent was born. This seemingly simple act creates a logical contradiction. If your grandfather died before your parent was born, then you would never have been born. But if you were never born, you couldn't have traveled back in time to cause your grandfather's death in the first place. The grandfather paradox highlights the potential for causality violations, events that break the fundamental cause and effect relationship we observe in the universe. If time travel were possible, it seems it would require some mechanism to prevent such paradoxes from occurring.
The quest to understand space-time and the possibility of time travel is a testament to the boundless curiosity of the human spirit. It's driven by our desire to explore the unknown and unravel the mysteries of the cosmos. Technological hurdles are immense, but what seems impossible today might be commonplace tomorrow. Humans have achieved feats once considered unimaginable. We've harnessed the atom, landed on the moon, and sent probes to the farthest reaches of our solar system. Each achievement was once deemed impossible, yet human ingenuity prevailed. The pursuit of understanding space-time is no different. It's a journey that will continue to inspire generations of scientists, engineers, and dreamers.